What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Security Plus certification exam. So let's get into it. In this video, we're going to dive into one of the most critical topics in cybersecurity, and that is protecting data. So data is often referred to as the lifeblood of an organization. It fuels decision-making, drives innovation, and if not secured, it can spell disaster. So let's break down the concepts, classifications, and strategies that you need to know to safeguard this invaluable asset. All right, so let's start with the types of data that you will encounter. So each type has unique characteristics and requirements for their protection. So the first one is called regulated data. And this is data that is governed by laws and standards like HIPAA for healthcare or GDPR for privacy. Organizations handling data, they must comply with strict rules or face hefty penalties. An example of this would be patient healthcare records or credit card information. Then we have what are called trade secrets. So think of trade secrets as the secret of a company. It could be a formula, a process, or a strategy that gives them a competitive edge. And exposure could lead to significant financial loss. An example of this would be Coca-Cola's formula or a proprietary algorithm. Then we have what is called intellectual property. And this includes patents, trademarks, copyrights, and other creations of the mind. So protecting IP, this ensures innovation remains profitable. And an example of this would be a software program or a movie script. Next, we have what is called legal information. So legal documents, this pertains to contracts, court documents, or anything tied to legal obligations. And breaches here, this can lead to lawsuits or compliance issues. So an example would be employee contracts or litigation records. Then we have financial information. This includes financial transactions, tax records, and budgets. If this information is compromised, it could lead to identity theft or financial fraud. And examples of this would be bank account details or tax filings. And then we have human and non-human readable data. So human readable data, this includes text files, emails, or reports that are easily understood by humans. And then we have non-human readable data. And this includes encrypted files, binary code, or machine readable logs. So in essence, protecting both types is critical. As attackers, they often target non-human readable data for exploitation. All right, so moving on, organizations, they classify data to determine its value and the level of protection that is required. And here are the main classifications. The first one is called sensitive data, and this is data requiring restricted access due to its potential impact if disclosed. And an example of this could be an employee's social security number. Then we have what is called confidential data. And this is intended for specific audiences and protected by stricter controls. And an example of this could be an internal business strategy. Then we have what is called public data. This is freely available and not requiring confidential measures. And things like this could be a press release or marketing materials. Then we have what is called restricted data, and this is data that requires explicit permission for access due to potential harm if exposed. And this could be things like source code repositories. And then we have what is called private data. And this is typically personal information requiring high levels of protection, such as medical or financial records. And then we have what is called critical data. And this is essential for business operations, requiring the highest level of security. And an example of this could be encryption keys or disaster recovery plans. Now, beyond classifications, understanding the states and location of data is vital. So we have various data states, and the first one is called data at rest. And this is stored data, such as files on a disk or a database, and you use encryption and access controls to secure it. Then we have what is called data in transit. This is data that's being transmitted over a network, and you want to protect it with protocols like TLS or VPNs. And then we have data in use, and this is data that is actively processed by applications, and techniques like memory encryption, they can safeguard it. And next we have what is called data sovereignty. And this refers to laws governing data based on its physical location. So for instance, GDPR, this applies to data that is stored in the European Union. And understanding these rules is crucial for compliance. And then we have what is called geolocation. So knowing where data resides and flows, this helps determine which regulations and risk apply. Now let's explore the techniques that are used to secure data effectively. And the first technique is called geographic restrictions, and this limits access to data based on geographic locations. So for example, blocking IPs from high-risk countries, this can reduce exposure. And then we have what is called encryption, and this transforms data into unreadable formats without a decryption key. And this encrypts data at rest, in transit, or even in use. And examples of this will be AES, or Advanced Encryption Standards, for file encryption, and HTTPS for secure web traffic. Next technique we have is called hashing, and this is used to generate fixed length outputs from data that ensures integrity. And hashes are commonly used to verify passwords and files. An example of a hash would be the SHA-256 hash for password storage. And then we have what is called masking, and this is used to hide parts of data to minimize exposure. And this is common in testing environments. An example of this would be showing only the last 4 digits of a social security number. And then we have what is called tokenization, and this replaces sensitive data with unique tokens stored securely. And this is useful for payment systems. So an example would be credit card numbers that are being processed by a payment processor. And then we have what is called obfuscation, and this makes data less understandable, but it is not encrypted. And this is used in source code to deter reverse engineering. An example of this would be obfuscated JavaScript. Another method is called segmentation, and this divides data into segments and applies tailored security controls. An example of this would be separating customer data by region. And then we have what are called permission restrictions, and this limits access based on roles and responsibilities. And the principle of least privilege, this ensures users only access what they need. So an example of this would be an HR employee that can only access the payroll data, but not access the system configurations. All right, so there you have it. This was a comprehensive look at protecting data through classifications, considerations, and methods. Now, whether you're securing trade secrets or personal information, these strategies form the backbone of modern cybersecurity practices. So make sure you understand how to apply these techniques in various scenarios, as they are fundamental for your Security Plus certification and, more importantly, for protecting your organization. Now, with all of that being said, let's do some of this check on learning. So the first question is, which of the following is an example of regulated data that requires compliance with specific laws or standards? Would it be marketing plans for a new product launch? Would it be social security numbers that are stored in a database? Would it be a company's internal process documentation? Or would it be a trade secret recipe for a product? And the correct answer would be, it'll be a social security number that is stored in a database. So regulated data, this refers to information that is subject to laws, regulations, or standards. Social security numbers are examples of personally identifiable information, which are regulated under laws like GDPR and HIPAA. And marketing plans, internal process documentation, and trade secrets are not typically regulated, although they may require protection. All right, next question. Which of the following data protection methods transforms readable data into a scrambled format that can only be decrypted with a key? Would it be hashing, encryption, masking, or obfuscation? And of course, the answer is encryption. So encryption, this is a method of converting data into a ciphered format to protect its confidentiality. Unlike hashing, encryption allows the data to be decrypted back into its original form using a key. Masking and obfuscation, they also alter data, but they are not reversible methods designed for secure retrieval. All right, and our final question is, a company's database contains financial records marked as critical and confidential. Which of the following strategies best ensures the protection of this data when accessed remotely? Would it be applying hashing to all financial records? Would it be using a geolocation-based restriction for remote access? Would it be encrypting the database with AES-256 encryption? And would it be applying masking to all financial records? And the correct answer is encrypting the database with AES-256 encryption. So encryption, especially with robust methods like AES-256, this ensures that data remains protected during transit and at rest. Hashing is used for integrity checks and not for securing data in use. Geolocation-based restrictions, they can help limit access but not secure the data itself. And masking, this is more suited for limited sensitive information visibility in specific scenarios, such as testing.